An interstellar visitor is passing through our solar system, and this is our final chance to observe this one. New images captured by the Hubble Space Telescope reveal Comet 3I Atlas just moments before it disappears forever, leaving behind more questions than answers. This is the last window humanity has to study this object as it escapes back into interstellar space. In this video, we'll explore how and when you can still see it, what the latest Hubble images have uncovered, and why this fading visitor still matters deeply to science. Right now, 3I Atlas isn't just another comet. It's a cosmic visitor that came from beyond our solar system and is already on its way out. Discovered on July 1st, 2025, by NASA's Atlas survey, this object is the third confirmed interstellar visitor we have ever detected, following 1I Oumuamua and 2I Borisov, and it's moving fast enough to escape the Sun's gravity entirely. This interstellar trajectory is hyperbolic, meaning the comet didn't orbit the Sun in a closed loop like familiar comets, but instead zoomed through our solar system once and kept going. As of January 25th, 2026, astronomers calculate its position far beyond Earth, receding and fading in brightness as it travels outward. In fact, the comet's visual magnitude is now around 13 or fainter, far too dim for unaided eyes. Only telescopes can catch it now. What makes this exit phase scientifically fascinating is not just the physical departure, but the unique observational geometry it offers. Around January 22nd, 2026, 3I Atlas reached a rare alignment known as opposition, where the Earth was nearly directly between the Sun and the comet, minimizing shadows and letting us observe subtle properties of its dust and coma in unusual detail. This geometry doesn't come around often, especially for interstellar objects, because they move unpredictably and rarely linger long enough for such clear alignment. That opposition moment was astronomers' last real chance to gather rich, high-quality data before the comet fades into the distant darkness. This is why observatories around the world, and even those orbiting spacecraft, concentrated efforts on capturing every photon of light they could. The exit of 3I/Atlas, in other words, is not just a departure, it's the final window for collecting a treasure trove of information about an object born in another star system. If you're someone who's been following this comet live, you've probably tuned in to public live streams like those hosted by the Virtual Telescope project in Italy. These broadcasts became the only practical way for the public to watch 3I Atlas as it faded, because its light has become so weak that ordinary binoculars or casual telescopes just don't cut it anymore. On January 22nd, the opposition provided a brief surge in brightness, not because the comet suddenly got brighter in absolute terms, but because we viewed it at the optimum angle, a phenomenon astronomers call opposition surge. The comet's dust and coma reflected more sunlight toward Earth, giving telescopes a slightly clearer and sharper look precisely when they needed it most. Even then, the object remained faint, around magnitude +13 or worse, meaning that even powerful amateur telescopes often struggled to pick it out from the background stars. Only larger automated instruments, like the 14-inch robotic telescopes used in the live streams, could produce images sharp enough for public viewing. This situation tells us something important. Visibility is not just about distance, it's about geometry, light scattering, and the physical properties of the comet's coma. As 3I Atlas recedes, its coma, the cloud of gas and dust around it, grows more diffuse. This makes the comet not just fainter, but harder to resolve at all. Over the next few months into spring 2026, even telescopes will struggle to detect it reliably, and by summer, it will essentially be gone from Earth's view entirely. Yet while this fading was predictable, the fact that it didn't disappear instantly allowed astronomers to gather valuable transitional data that tells us how interstellar objects actually behave as they leave a star's influence. This turn of events makes 3I Atlas both a farewell show and a scientific playground. While many observations came from ground-based telescopes, some of the most intriguing data emerged from the Hubble Space Telescope during that rare January 22 alignment. In a set of 6 long exposures taken over about half an hour, Hubble captured the comet's coma elongated nearly 100,000 kilometers toward the Sun, hinting at details about the dust distribution and activity that are hard to see from Earth's surface. This elongated glow isn't just pretty imagery. It speaks to how the comet's surface and interior react to solar heating even as it retreats. Unlike typical solar system comets that tend to form tails away from the Sun due to the pressure of sunlight and solar wind, 3I Atlas is showing structural asymmetries and jets that don't align with simple models. These features suggest a complex interplay of dust particle sizes, gas release patterns, and perhaps a surface shaped by processes foreign to our familiar comet population. Earlier Hubble images, including those from July and late 2025, already revealed subtle twists in the comet's anti-tail and jet structure, indicating that it wasn't just the tail away from the Sun that mattered, but also how dust and gas were being expelled in unexpected directions. This ties into broader questions about the composition and internal structure of interstellar bodies and how they differ from or resemble comets formed within our own solar system. What makes the Hubble observations especially vital is that they extend beyond simple brightness or position measurements. They give us physical clues about particle size distributions, gas interactions, and even potential activity cycles as the comet cools and depletes volatile materials. In essence, these final images are like reading the last chapters of a book. They might not reveal all the mysteries, but they give us powerful hints about what the rest of the story looked like long before 3I Atlas ever encountered our Sun. 3I Atlas may be fading from view, but what it has taught us is far from over. In its brief journey through our neighborhood, it offered scientists a rare chance to study extraneous cosmic material that predates our own solar system and may carry clues about environments billions of years old. The fact that its final passage occurred with an opposition alignment and that telescopes around the world captured it under exceptional circumstances is nothing short of astronomical serendipity. Unlike many comets that remain bound to the Sun, 3I Atlas came from the galaxy beyond and refused to stay. In doing so, it challenged our tools, sharpened our methods, and reminded us that space is far bigger, more dynamic, and more interconnected than we usually appreciate. Even as it becomes too faint to see, its legacy in data and understanding will continue to shape our view of how interstellar objects behave and what secrets they carry. If you enjoyed this video, support us with a like, share, and subscribe. It truly keeps our journey going. Thank you for watching, and see you in the next video.